Hey everybody, Dr. Nelson here. This is a video about how to graph quadratic functions using a basic input-output table. Alright, so we're going to do one problem together, and then you have a chance to try one on your own when we're done, and then at the end you can see how you did. Alright, so we're going to graph the function y equals x squared minus x minus 6, and I've already made an input-output table, and I put in some x values. I'm going to add one more. I'm going to add the x value of 3. So if you do that for me, that'd be great. And all you have to do is plug in the x values and use PEMDAS, the order of operations, to figure out the y value. All right, so please write down PEMDAS. That is important. You must always, always, always follow that. So when I plug in 2, 2 squared is 4. Take away 2 gives you 2. And then take away 6, we're going to get a value of negative 4 for y. All right. When I plug in 1, we're going to get negative 6 for y. When I plug in 0, we're also going to get negative 6 for y. When I plug in negative 1, well, negative 1 squared is 1. And 1 minus a negative 1 is adding 1. That makes it a 2. And then 2 take away 6 gives you a negative 4. Here we have a negative 2. So negative 2 squared is 4. And when I subtract the negative 2, that's like adding 2, which makes it 6. And then 6 take away 6 gives you a 0. And then when I plug in 3, 3 squared gives us actually a 9. I'm going to write that in. So 9. 9 take away 3 gives us a 6. And 6 take away 6 gives us a 0. So we get a y value of 0. All right, so now that we have our input-output values, let's plot them. So we have 2, negative 4. Will be right here. We have 1 and negative 6, which is right there. We have 0 and negative 6, which is right there. Negative 1, negative 4. Negative 2, 0. And 3 and 0. So this is going to make a parabola that looks kind of like this. So I'm going to actually extend it in both directions. So it's going to be kind of like a U. Like that. And now that's not perfect by any means, but that's the general shape of the function y equals x squared minus x minus 6. Now there's a few really important things you need to know about this graph. One is the y-intercept. So let's identify the y-intercept. So that's going to be down here. So it looks like the value 0 and negative 6 is the value of the y-intercept. If you notice, there's a negative 6 over here, and we'll get into that later on. And then we also want to look at the x-intercepts, and these are going to be called roots, which we'll talk about in another video. But here's one x-intercept, and here's another x-intercept. So the location of this one is negative 2 and 0. And this one is positive 3 and 0. Okay? And these values right here have really important meanings when it comes to quadratic functions, which you're going to learn about again in another video. Alright, so now that you understand how to graph a quadratic function using an input-output table, why don't you pause the video and try the your turn problem now, and when you're done, hit play. You can see how you did. Alright, good luck. Alright, welcome back. Let's see how you did with this your turn problem. So again, we have the function y equals x squared minus 2x minus 3. And we have an input-output table. So let me plug in the correct y values for the inputs. So when x was 2, y should have been negative 3. And let me get my pen here. Alright, negative 3. When x was 1, y should have been negative 4. When x was 0, y should have been negative 3. When x was negative 1, y should have been 0. When x was negative 2, y should have been 5. And when x was 3, y should have been 0. So again, if you made a mistake in any of this, again, it means you probably made a mistake by not following the order of operations. That is a must. It's a major concept when graphing using the input-output tables. So now let's graph the graph here. So 2, negative 3 is going to be a point right here. And we have 1, negative 4 is right there. And we have 0, negative 3. That's right there. Negative 1, 0. Negative 2 and 5. That's way up here. And 3 and 0. Alright, so now if we connect the points, it's going to look kind of like this. And again, this keeps on going in this direction. So add the arrow there, add the arrow there, and there it is. Okay. So what is the location of the y-intercept? So the y-intercept should have been 0 and negative 3. And for this one, we have two x-intercepts, or roots. One is at location 3 and 0. And the other one is at location negative 1 and 0. And there it is. All right, how'd you do?